Hi, and welcome to this quick tool review. This time around we'll be taking a look at the Harbor Freight new brand clamp meter. And Harbor Freight's been trying to reinvent themselves by creating a bunch of new sub-brands within their store. This is the Ames brand, which has a whole range of meters and test instruments. Looks like they have at least 5 different versions of the meter here, and this is the most elaborate of them. It's still fairly inexpensive. It was a little over $100 as I recall. I needed something that was high current. It claims the clamp meter is 1,000 amps, so that was going to be handy for a project I was planning. So I thought I'd get it and try it out. We'll see if it's accurate, and we'll see if it's reliable long term, I guess. We'll just see how the build quality is now and maybe predict long-term reliability, since I won't be able to actually know how long it's going to last until it fails. Alright, let's open up and take a look. Alright, so inside the box they gave a cloth bag to hold the meter, and that's a pretty nice touch, especially if you're a technician that throws all your tools in a bag. This will give it a little bit of protection. That's a nice touch. So here's this guy inside, and velcroed in place. Comes with a 9-volt battery. That's a nice touch. And here's a set of test probes that have insulating tips. Look like they're removable. I'll check that out. Let's see, is that true? So I don't have 2 hands handy here because I'm at work where I have access to better test instruments, but they do have tip insulators that snap on, which is kind of a nice touch. The wire is not, it feels like PVC wire. It's not the rubberized wire that you get with a Fluke. But then again, the price is nothing like you get with a Fluke. It also comes with a manual. So let's open this guy up, power it up. So before we get any farther, the plastic feels very much like the Fluke plastic. It's a hard plastic. I don't know whether it's nylon reinforced or glass fiber reinforced rather. But it does have a rubberized overmold. That's a nice touch. Feels good in the hand sticks. Fit and finish seems pretty decent. The clamp action is nice. The dial has really nice detents. It's a little sloppy side to side. It's spring-loaded pushing up, but obviously they give some allowance for the shaft, and it's not a really tight fit because it doesn't feel like it, but that's cool. It looks like they have a battery door on back, which my older Fluke 87 did not have. You actually had to pry the Fluke apart, which I hated. Every time you wanted to change the battery. And interesting, this looks like one of the Harbor Freight brand. It's a Thunderbolt Magnum battery, heavy duty. It's zinc chloride, so it's not even an alkaline battery. That's very interesting. But they give you a battery, so can't complain too much. One negative note is the screw that holds the battery lid in is not it is not captive, which it should be. That's a real bummer, because if you're on a job site, that tiny little screw almost guaranteed to get lost. On the flip side, the battery case does snap in, so you probably could get by without a screw in there if worse comes to worse, but it's the little details that can matter, and that's unfortunate that they didn't think of that. So reading through the features, this meter has some nice features that a lot of other meters don't have. It'll measure inrush current, which is a nice feature. Often tends to be a lot higher than average running current, so that'll show you current on motors starting up, I would guess. My Fluke certainly doesn't have that. It can measure duty cycle, it can measure frequency. It has a backlight built in, that's the backlight. Can do min-max. Continuity, and the non-contact voltage, which uses this tip. I didn't realize that. So if I go back, reading the manual here, so that's better. So now it does get the meter first time. But gets it in the wire there. And they actually suggest that you have non-shielded wire, so the fact that it's working through that is a plus. I guess better than they suggest it could work. All right, it also measures DC current, as I said, but you got to get the polarity correct going through. So there's the positive side, negative, so I'm assuming that the DC current needs to flowing positive, negative, the wire needs to go in that direction. We'll test that theory out, and we'll check out some accuracy. So here's a 3/4 of an amp, roughly, with the fluke in series. Very close. Here's turning it up. This is DC current. There's 3 and 3.01 on the fluke in series. Very close. There's 5. 5.11, 5.07. So close. Not bad for a clamp meter. So the clamp current rating is well within the 2% spec they suggested. Well, the probes you never expect to be good. The probes are absolute crap. You can see how sloppy they are in here. Never seen that before in a meter. Here's the fluke. They snap in, and these aren't even fluke original probes. These are Pomona. And the Pomonas are tight in here too, so it's not at least the base unit. You can always get aftermarket probes, but it's really unfortunate the probes are worthless. That is totally loose. No confidence in getting a good connection there. So I don't know if you can see this, but I spread the fingers out and it makes better contact, it's tighter, but to be honest, probably should just toss the probes, get a new set. There's DC voltage. So here's a 100K 5% resistor on this guy, 180 ohm. So here's capacitance of 0.47 microfarad, showing up as, hard to read, 0.455. Let's see if we can get the backlight on. There we go, that's easier. So 0.47 showing up as 0.455, but they're only something like plus 10, minus 20 or something, that percent accuracy on the caps to begin with. So here's a 0.01, and smaller value caps are more difficult to measure because probe capacitance starts to come into play more and more, and you really shouldn't do it with long probes like this and alligator clips, but we seem to be getting away with it. So 0.01 is showing up as 0.01023, and here is a diode, 1N4002. Typically the way they measure a diode's forward drop is to put a milliamp forward and measure the voltage. So here's some high current measurements. Normally what you do to verify would be to have a very small low value known resistance and measure the voltage drop across it, and that way you could compare with a very accurate voltmeter, but I don't have one of those calibrated resistance. So this is a piece of steel here, and these are a couple wrenches. Here's a variac, which I'm going to turn on, which lets me control the input to this transformer. So here we are going up, and you can probably hear it starting to hum at 200 amps. Here's 400 amps, and you see that it's starting to affect the wrench. Here, let me move this again. $800,000 amps, almost 900 amps. The immense amount of current is creating a magnetic field. So here we are hitting almost 1,000 amps. Ooh, and starting to melt everything. So the steel bar started to melt, and it's melting the plastic on the current sensor. Ooh, too hot to touch. So there you go. Seems like it's working pretty well. I can't verify the accuracy though. So here's a quick test of the inrush current. So what I did was I took a cheapo computer cord and I cut off one end, put a female on it, split the center so that I could get to the black, the hot conductor. So here is how much this guy draws in steady state. So the no-load current is about 4.7 amps. Now, this guy has the ability to measure inrush, which is a neat feature. You push and hold, and it says 42 amps. That is quite a bit. An interesting comparison, since I'm not quite sure how it's doing the inrush calculation, but if we did a min-max, let's see what we get with a max, because inrush is a lot like what is the max instantaneous current as it tries to turn on. Because remember, a motor is a giant inductor, and inductors don't want to see a change in current. So when you try and get current to flow through it, initially it looks like a short because it's trying to stay at 0. So they end up with large numbers on startup. So the min-max feature only captures 21 amps. Let's try it again. Yeah. Versus again, here's the inrush. 42 amps. All considering that under no load, this thing draws about 4 amps. And let's see, what is it rated on the side? 7.5 amps nominal. So I guess that's under normal load conditions, 7.5 amps. Anyways, so that's a really nice feature. If you're interested on a motor, what you need to cover for instantaneous current, it got you covered. That's a nice feature. So one more feature the meter has is when you turn on the backlight, it actually has an LED that lights up between the clamps so that you can see which wire you're trying to clamp on for current measurement. That's nice. So before we go, I thought I'd take a quick look inside this guy. I'm sure a lot of people were interested in how it's constructed inside. I know that I am. Looks like 3 screws. This thing actually snaps pretty darn well. So even if and when you lose this screw, which seems like a likelihood, you're going to be okay, I think. Pop the battery out, so let's see how this guy... Oh, it comes apart pretty easily. Alright. Wow, better than I thought. So, the... oh, if you can look, these are not particularly good. You really want some sort of spring connector, not sort of bent metal design. So not great for making contact. Looks like they've got an MOV for over voltage protection. The crystal for the microprocessor on this is just floating, and it might have been a better idea if they'd taken some hot glue or something to hold it in place, because crystals are sensitive to being dropped, although it is only being supported by the lead, so that does provide a little buffer right now for it. A nice plus is epoxy fiberglass PC board. You don't see that in a lot of inexpensive stuff from overseas. They use paper phenolic, which is the orangish stuff. This stuff's a lot more flexible. I noticed that they did take care on the PC board layout too. You'll notice all of this grid work here. That's because they're providing shielding all over the place. So when you're trying to do accurate measurements at low voltages and currents, you've got to be careful to shield your lines to make sure that you don't get outside induced fields. So that's pretty nice. They don't do a lot of really careful wire retention. So when I put this back together, I got to be careful that I don't cut the LED wire there. So overall, the construction seems good. It's surface mount entirely. Without digging in deeper, I'd say they did a pretty reasonable job. It's better than I expected inside. Could have done a better job on the bananas. Again, this is your primary interface to the whole measurement apparatus. So if you do this all perfectly, but this isn't great, then you've got a weak link, and you can affect your measurement accuracy. So I wish they'd do this a little bit better with higher end banana plugs. And the fluke leads inside, instead of being this split prong style, actually have a central shaft with a spring shell on it that pushes out to make contact with this. Now with that combined with the fluke probes, these would probably be okay. And I guess this one they're relying on these bending out, rubbing. So maybe these don't need to be any better. We're just thinking a little further here. In any case, I think the construction's better than I expected. So I'm generally pretty pleased, especially for the money. So my overall take on this guy is pretty good value, pretty good bang for the buck. I haven't compared against like BK Precision or one of the other guys, or even a Greenlee, which I would suspect is made by a similar group. If I had to guess. This guy has a lot of features, a ton of features built in that you only find in the more expensive meters. Here's my Fluke 87, and this has more features than my 87 does. You've got min-max, you've got backlight, you've got frequency, you've got duty cycle percentage, you've got manual range select, you've got non-contact voltage sensing. The Fluke definitely doesn't have that. You have clamp meter, which this does not have. You have up to 1,000 amps. This goes up to 10 amps. AC and DC current, which is not at all common for all of these clamp meters, because it's a little bit hard to measure DC current because it's not changing. It also has inrush current, which is great if you want to do the max current that a motor is going to draw. Has a light to illuminate the clamp area. The plastic is feels really good in the hand, and the overmold's good. It's nice stiff rubber like this case on my Fluke 87. Battery case is hard plastic like the Fluke's, very similar. However, the non-captive screw is a negative, but if you lose the screw, it still snaps in. So it's almost like they thought about that happening and planned ahead, because it snaps in, you could live without the screw. The probes were worthless. You can fix them by bending the tines apart, but it's probably better just to get a decent set of probes, because the meter is more accurate than the probes are going to give you if they're intermittent. So probably worth getting a decent set of probes. If you need extreme accuracy, then you probably should buy a better meter. This is reasonably accurate and great for the price. This is in the few $100 range. This is in the $99 on sale range, and it's their top of the line. If you don't need 1,000 amps, you can get a lot of these features in one of their lower models, so that's also really nice. Generally, I give it a thumbs up for the price. Not as accurate as it could be, crappy probes, reasonable case. Thanks for watching. Hope you enjoyed it. Hope to see you next time.